I'm Anil Kumar, and in this video we will learn how to find characteristics of sinusoidal function from the given transformed equation and how to sketch a graph from there. So we are given y equals to minus 2 sine 2 times theta plus pi by 2 plus 2, and we need to sketch one cycle of the given function and describe its characteristics. Let's begin by the characteristics, right? So from the given equation, let's write down the characteristics which you can directly read. So minus, it means it gets reflected on the x-axis. So starts with the minimum kind of. Do you see that? Starts with the minimum, one cycle. Now 2 means, so minus means reflection on x-axis, correct? So we'll remember that. Now 2 gives us the amplitude. So we know amplitude for this wave is 2 units. Plus 2 here will give you axis. So we'll say axis is y equals to plus 2. Now from axis and amplitude we can get the maximum and minimum value. Maximum value will be from the axis it can go 2 up and 2 down. So it is 2 plus 2, which is 4, and the minimum value for this sinusoidal function will be 2 minus 2, which is 0. So these are some of the values which we could calculate from the vertically stretched and vertically translated 2 units. Now let's get into the inside values, 2 and pi by 8. That 2 gives us the time period. So these values, let's consider them now. So 2 is the time period 2 pi by 2. So when you divide you get pi. So pi is the time period. As far as the phase shift is concerned, phase shift is pi by 8, and that 2 to the left. So let me write minus pi by 8. So these are the characteristics for the given function. So approximately, if I have to roughly sketch this graph, right? So this graph kind of looks like starting with the minimum, which in this case is 0, and going to the maximum, which is in this case is 4. And the axis being at 2. So it kind of here. So basically it starts from kind of like this. So it moves some unit here, so it could be kind of like this. So that is how one full wave is, where it starts from pi by 8, right? And the time period, as you can see, is pi. So it ends at pi minus pi by 8. So that is going to be the graph for the function, where this point is pi minus pi by 8, right? And the maximum value and the minimum values are 4 and 0, as you can see. So that is going to be our final graph. Okay, so we have an idea of what we are going to sketch. Now let me share with you some more characteristics which will help you to sketch sinusoidal function. We call it 5 points. So let us consider the 5 points which help to solve or graph a sinusoidal function. So if I have a sinusoidal function, 5 critical points for us are, let's write them down. As you know, sine function basically starts like this, right? Sine function basically starts like this, where it starts from the axis, right? And this is your original sine function. So you could write from here that for theta, what are the y values? When theta is 0, y is 0. And when theta is pi by 2, y is 1. When theta is pi, y value is 0. When theta is 3 pi by 2, that's minus 1. And for 2 pi, the value is again 0. So these are your values for the sine function, right? So this is for sine theta, which is not transformed. Once you transform, these points will change. For us, the transformation is that the theta value, theta value becomes half of the original value. So we have half of theta here, and then we have to take away pi by 8. As far as the y value is concerned, we have to multiply it by minus 2y, and add 2. So those are the new points. So these are the transformed points for the function, right? So let us list the transformed points for the given function. So half of theta minus pi by 8 will give us minus pi by 8 here. On this side, 2 times 0 plus 2 will give us 2. So at minus pi by 8, we'll start with 2, right? So that is the point. Then we have this point. So if I do half of that, it becomes pi by 4. And from pi by 4, I have to take away pi by 8, right? So pi by 4 is 2 pi by 8. From 2 pi by 8, I have to take away pi by 8. So 2 pi by 8 take away pi by 8 is pi by 8 for us. And here 1 times minus 2 is minus 2 plus 2 is 0, right? Here pi. So half of pi is pi by 2. From pi by 2, if you take away pi by 8, you get 4 minus 1, 3 pi by 8, right? So you get 3 pi by 8. And the value will be minus 2. Minus minus becomes plus. So plus 2, which is going to be 4, right? Now, on the other hand, 2 pi, half of 2 pi is pi. Taking away pi by 8 will give us 7 pi by 8. And the value will be 2, 3, 4, 5, 1. So we kind of missed one value in between somewhere. So, okay. So we'll take away 3 pi by 2 also. So 2 pi will be 7 pi by 8. So 0, that gives us 2. So let's squeeze it 3 pi by 2 now. Half of that is 3 pi by 4. Now, so that is what I'm going to squeeze here. We missed this value. Right. So we have 3 pi by 4 minus pi by 8. 3 pi by 4 is 6 pi by 8. That is 5 pi by 8, right? So 5 pi by 8. And the value will be minus, and minus gives me plus 2. This will be plus 4. And that one was for 2, right? So that one was for 0. So 0 times something is 0, plus 2 will give us 2. So these are our transformed points, correct? So you may do this calculations using your calculator, or take some more time to do it. Now you get these points. Once you get this point, you can actually graph the function, right? So that is the whole idea. Here is a rough sketch. So how do I roughly sketch this graph? So let me show you a rough sketch of the graph. So let me do it here. Since we know that the maximum is 4 and minimum is 0, I'll kind of take the scale kind of like this. So we know that the maximum is 4 and minimum is 0. So I'm just drawing a dotted line here, indicating that to be 4. And axis is at 2. So I'll draw axis at 2 here, right? So this is my axis. So let me label these points. This is 2, this is 4, this is 0 for us, correct? The wave actually starts from this side and then moves, and these are my points. So minus pi by 8. So what we should do here is, first we can draw a wave which is one cycle, and then we can move it pi by 8 units to the left. So that is how I do. So first step is sketch the wave, which is let me upside down, since it is transform function, kind of like this. Okay, so this is my wave, right? So where these points for us are pi by 2, pi by 4. Do you see that? So 3 pi by 2. These are my original points with the reflected wave and vertical stretch along with horizontal compression has been applied. Now to this, we'll move each point pi by 8 units to the left. Do you see? This is pi by 8 units to the left. So once you move pi by 8 units to the left, you get your transformed function, which is one wave, right? So where this point is minus pi by 8. Do you get the point? and it ends here, which is 7 pi by 8. Correct? So on your graph paper you can get a very accurate graph, but my suggestion here is do it in two parts, right? So do it in two parts. First part is sketch minus 2 sine 2 theta plus 2. Do you get my point? And then you sketch minus 2 sine 2 theta plus pi by 8 plus 2. So that is the second final wave. So if you do that, then you get very good result. You could also use your points to get the 5 points accurately placed, right, and get a very perfect graph, right? I hope these steps help you to sketch a sinusoidal function. Thank you and all the best.